Now we want to find an example where all the un are strictly concave, but the limit u is not. So how do we do that? Well, recall from earlier that we said taking the limit preserves weak inequalities, and in general it doesn't preserve strict inequalities. And I gave the example that just because 1 over n is strictly greater than 1 over 2n for all the natural numbers, then because both of these converge to 0 for n tending to infinity, then it does not hold that the limit of this is greater than the limit of this. Well, we can think along the same lines over here in some way, where we consider a sequence where there's something tending to 0. So we all know that u of, if we let un of y be given by something that has to do with minus y squared, then it would have some kind of sad smiley look going on over here. And if we just scale that with some scalar value 1 over n, then that's just the same as making it a bit flatter. So if we let un of y be given by minus 1nth times y squared, then these functions un, they will just become gradually flatter and flatter and flatter. And given y in I, we note that the value un of y equals minus y squared over n, and that tends to 0 for n tending to infinity. So this is the limit u of y. And now we note that u of y is not strictly concave, because u of y is just a constant value 0. It's just a constant value 0 over here along this line. It's just 0 going just here along the x-axis, and that's merely concave and not strictly concave. So we have now found an example where the un are strictly concave but u is not. And what we conclude from this is that even though a limit of concave functions tends towards a concave function, then the limit of strictly concave functions need not tend toward a strictly concave function.